big data, all these as a part of the next generation smart city planning. So for the next 50 years or so, uh, what world will turning into, each and every country, what we will do, we will try to build our city, our areas, our states in terms of smart city concept. So IoT, big data, these are the necessary and mandatory part of this smart city planning concept. So our research, both the renewable energy, then electronics, then the biomedical, then civil, then industry, all are turning towards this smart city planning. So IoT is very important. So what actually our students can learn and get benefited in this IoT and big data and all these things in student life. So this is the real big picture, because we researchers, we do our expertise kind of researches all over the world, but what can students do? So is it researchable in university level, or maybe in the school or college level? And how far a school college student can get involved into high impact IoT research? Consequently, the college and the university. So what I will do, I will focus the major parts of high impact IoT research in university and like undergrad and postgrad study level. So from there, Dr. Aravind, my another colleague, my dear colleagues, when I was doing my PhD, he was in Malaysia at Taylor's School as the director of Tripoli. So we had gone to distance around 10 years or so. So he will present the next step. So let's discuss the studies, the research opportunities in IoT in academia level. So before going to that, what I will do, I will tell you the research impacts in university from multiple dimension, which are giving significant values to the next generation technological advancements. Suppose smart communication. We have a V2G, B2G, vehicle to grid, billing to grid, distributed renewables. All these things are the part of the smart city concept, and IoT plays a significant role of in that. So, any prototype development in this area. Suppose we are making a demo prototype of smart grid model. So we all know G2V and G2B, which is grid to building and grid to vehicle. Grid to building is a normal smart grid system. So power generation, distribution, and consumption. Now we are on the stage, the high state countries, they're high tech countries, they're on the stage of establishing G2V, grid to vehicle. So most of our vehicles now they are hybrid. So after 10 years or 20 years or so, so there will be electrical vehicles. So they need to be charged wirelessly in smart petrol pumps, cafeterias, and all. So these are being implemented both in prototype level, and uh, few of the countries like Japan, America, they are also launching it. So then what we do, we going one step ahead through IoT and big data and other technological interface, in, planning V2G and B2G, which is vehicle to grid and building to grid. So these are the latest technologies, distributed renewables, mini power grid. So where if there is a power failure in one place, so in through distributed renewables, rooftop wind turbine, solar panels, we connect each building, then we make a power hub, then we put it in the grid. So this kind of things, IoT is very necessary. So in the university level, any research lab can do a prototype testing for this mini distributed renewable station, and then can conduct research on that. So in that case, the feasibility and cost effectiveness are a big challenge. So every big research plan gets a zero value addition if that does not get executed commercially, if that is not commercially viable. So once we make a prototype in these areas, we need to make sure that the business modeling is there. So it's feasible to install. It does not have a high value impact, abnormal high cost, neither like it has a complex structure to implement. So then we go to the smart vehicle and biomedical interface, those areas. So there are enormous opportunities. As you know, we already have the 3D printer and all. We are planning to install IoT based sensors in biomedical. So you can right now there are interfaces and machines that you can measure your ECG through IoT machines, and you can see the result right now in the mobile. There's already some smart instruments there available in the world. So these all are IoT based. So the challenge is that to make it easily viable and easily available in the market, cost efficiency again, so that anyone can bring a pocket ECG machine, IoT based, and suppose they take it, it's portable, and anywhere. If we accompany our parents, then any problem anywhere, we can measure it right now. We can see the result in the mobile, and then we can send it to the doctor in WhatsApp for the immediate medical assistance. So these all can be done through IoT. And the university level, if you make an high impact IoT research lab, you don't need too many of the machineries. Okay, in a 1000 square feet, we already have one IoT lab in our university. So based on the experience, if we have a 1000 square feet area, and then we have a few devices, there needs to be few segments and sectors where you have a complete setup. First is the IoT gateway. So IoT gateway, then IoT kit, then some virtual assistant machines, then some smart devices, then maybe three different hubs for AI and robotics hub, then renewable energy hub, then smart electronics devices and communication hub. So all these three hubs, if we incorporate through IoT, and then bring the interface in a mobile or throughout, we can install it in the whole building. What we plan in our university, that through the IoT lab that we are having, we are installing three major hubs in the IoT lab. One is the renewable energy interface, another is the AI and robotics interface, and another is the biomedical interface. So what we're gonna do through our AI robotics and smart communication interface, we're making our campus as smart cities, a smart building zone, intelligent building and smart building zone. So all these things are being done by our expert researchers, our faculty members, with 13 research cells in the Department of Tripoli under School of Science and Engineering that we're having under the active collaboration of the final year project students. So this is where the university students can get benefited. Suppose in a university, we launch an IoT lab. Okay, so we incorporate all the major segments of this IoT device, IoT Groove virtual technology, then IoT kits and all. Then few sections for renewable, maybe biomedical, maybe AI robotics, maybe smart vehicles. All these are the next generation technological advancements for smart city planning. So all these are extremely important. So all these areas, if we incorporate our research centers in this IoT lab, and then what we do, engage our students, final year project students from undergrad, then master students from our MSc, and then PhD students in these areas. So they can conduct high value research with the active supervision and guidance of the faculty members, then come up with a prototype. And then again, this prototype needs to go through troubleshootings, then a viable and feasible business modeling has to be there. This is very important. Otherwise, because the IoT has to be commercial, any IoT setup. In civil engineering also, in environmental science, there are a lot of sensors right now: carbon monoxide, carbon dioxide, all these sensors. Like the IoT incorporated real-time monitoring interface. This is a very important parameter for civil and environmental science. So right now, any portable, cost-efficient, IoT-based sensor that can measure the uh, carbon monoxide, carbon dioxide, and all these parameters eh, are extremely important tools for industry. So again, there are huge prospects and play areas that the students can explore in their lab. Consist of IoT instruments, machineries, and as I said before, the next 30 years, money, IoT, big data, all these will rule. So the students should be inclined and should be motivated towards these areas right from now, so that after 5 to 10 years, when things will be totally active in full scale, so then our students can incorporate with the system. So the research, uh, what I will say, not the research only, also the commercialization. So one thing is very important: innovation and commercialization. Both of the things are important for IoT implementation. Innovation is actually the research. You do conduct research, then you discover something, you create something. Then the next stage is the business modeling and commercialization. So both of the things, when you incorporate, and then you come up with a, suppose, a biomedical device, MRI, smart MRI device through IoT, or a smart ECG or eco device through IoT, and which is commercially viable and easy to maintain and low cost, then you can establish it in the market. But suppose you discover a device which gives so good authentic values, but extremely expensive and very high maintenance, is of high maintenance cost, so that also will not do that much of good, so both of the things are important. So so my part, I think this will do for me right now. So I'm extremely happy to be present for today's seminar, and I will give the floor to Dr. Aravind right now. So let's hear from him, and also all the best. I don't know if I get disconnected somehow. I will try to stay for the entire event. But if I get disconnected somehow, then this is goodbye for me. So I hope you enjoy the seminar, all the participants. And from Canadian University of Bangladesh, I wish you all the best. If you ever have a chance to come to Bangladesh, please feel free to visit Canadian University of Bangladesh. And I will share my email ID later on with Mr. Bala and Dr. Arabin. So if any assistance is needed for establishing IoT lab in any of the universities or colleges, feel free to consult with me. We have a full setup ready, so I will be happily uh, helping you. Thank you. Dr. Aravind, please.
Hi, over to you, Arvind.
Yeah, thank you very much, Dr. Shahrukh and Bala. I think I start with where Shahrukh just finished off. Whatever the universities generate as knowledge creation, it should be applied somewhere in the practical case. If it is not applicable for the practical case, then there is no point for us to like commercialize this knowledge generation. So that's what it means by the value creation. Value creation is something like what type of value you create for yourself in a particular purpose. Say, for example, I'm studying in an engineering course. So after I finish my engineering course, what type of value this engineering course is going to provide, right? Particularly for the society, right? The end point of engineering is all about serving for the society, or developing some sort of a knowledge for the society, which can be a practical application, or it can make it as a low cost device that can support people's day-to-day life part here. So value creation is very, very important. And when you create this value in industry is what we call as an industrial IoT, or industrial Internet of Things. That so to understand the proliferation of this IoT, we need to know first of all like the background of the what's so called as industrial revolution. As you see from this slide, typically the first industrial revolution where we talk about the steam power generation is in 1800s. The second one gave us an opportunity to know about with the electricity as the key core for us to understand the process. Of course, the proliferation of the robotic into the market, right, makes it systems to a system to become fully automatic or semi-automatic. Uh, so during the transition of the in the second revolution and third revolution, as you know, that the moment when you think about the semi-automatic or fully automatic, it comes to a mind like it's the job security, right? Uh, so that's what the fear of the transition between the second and the third revolution. And of course, the third revolution is trying to balance out with a number of product in terms of the quantity, right? So that actually balance out to the retrenchment of the jobs that is actually taken by the robotic systems there. And of course, between the third and the fourth revolution primarily belongs to the computer generation, the computer and communication generation, where if you see from the transition from the previous industrial revolution, takes about 40 to 50 years of time for a technology to boom from first to second, for example, second to third. But you look at the fourth industrial revolution, the transition is very fast. Uh, like for example, it's around 15 years already. We can see, like a smartphone connected to your computer, to your television, to anything in your whole of the house. If you put a sensor, connect to the some sort of cloud there, then it is under your single mobile control there. So this is a jump of what we see as a growth in the industrial revolution in the third and the fourth revolution. Even if you look at the communication technology in parallel, like rarely we know about 1G, 2G, 3G. The transition is very, very slow until we see the 4G and the 5G is picking up. It's a very, very high speed into the market there. So we have to understand, and the reality is like everything is going to be connected in through some sort of network, right? Either it is landed or it's through the mobile network there. So as you can see from here, I'm not here to promote IoT, but I'm just trying to put a case before you guys to understand the impact of this IoT in the real scenario, right? So see here, SDG stand for Sustainable Development Goals, which is considered to be the most important challenges we are going to face in the next century, at least for the next century. Yeah? And if you see from here, the 75% of the projects. 75% of these IoT projects concentrates on 5 SDG. And if you look at the SDG, is all related to our own like a socio-economical issues there. Like, health is going to be a bigger challenge. Or health is, in alternative, health is going to become like more longevity, is because you have more number of opportunities to become like your medical industry is so developed, right? So your health is going to be pushing to a longer duration in the world. That means the longevity will be more, right? Similarly for the energy, if you look at the energy aspects, like all the devices there, right? So number of devices there, that means number of devices needs power, and the power is going to come from where, right? So that's what the next challenge is going to be. And of course, this is going to change the model of the industry innovation in a different perspective. That means you cannot see in the future as a separate as an university and an industry. University and industry is going to be a co-working space, meaning that your labs in the universities is going to be the product making for the industry when your labs is not utilized by the students, right? This is what we see as a future growth from here. Of course, this will lead to a sustainable cities and communities. Sustainable here means like that is self reliant. That means it takes up the energy from its own system, and it does not bother the existing infrastructure there. And of course, it's also tally with that of the responsible consumption production. Responsible consumption production here means, like for example, energy saving devices at your own home, right? So it saves energy by 1% in per home. So if you look at a huge market, like the amount of energy that is saved is huge value here. And this one is possible with the help of a sensing device. The sensing device can tell, like if people are not around, for example, you can automatically switch off the light. As you know that you can see in most of the hotels there, it's an automatic switch on and off lights there, right? So we need to understand the background, like industry 4.0 is growing very huge, and it is the major or the crux of this industry 4.0 is going to be sensors, and the connection of the sensors with the network, right? And the network needs to perform some action, right? And this action should lead us to have a better what is called better engineering application there, right? So two things, as I mentioned, like one is the communication need to be optimized, right? The second thing is like uh, it need to have system need to have a self diagnosis. That means it need to understand if a system is going to shut down, or it is automatically going to go into the rec mode. It should automatically disconnect from the system, and it need to diagnose the problem, and if possible it need to self heal, so that it will reduce the downtime to a longer perspective. So these two things are very crux or for the industry, because in the industry time is money, right? If you think about if we talk about some of the industry people, they know that like every minute is money there, right? And if you can optimize this process, make the process to be faster, right? Ultimately it can increase the production time. And of course the production time is the communication to optimize. Self-diagnosis basically to reduce the downtime. In both the ways it will increase the revenue as a whole, and that is considered as a value for the industry, because in industry I talk in terms of the dollars and cents for us. This is coming from a survey. As you can see here, IoT as a hub for the industry 4.0. Two major things, I think Bala also mentioned during the introduction of the seminar, is about the smart agriculture. So whether this agriculture can be modernized with the help of these sensors or not, right? So we do one project in our university regarding this smart agriculture, where we use a drone as a key component, and we use this drone to form as a data lake, right? For example, if the remote places are where you are not able to communicate, where you're not able to access that, right? The drones can go there to collect the data, or they can station there as act as an antenna, as a mobile antenna there. Then it can transmit the data to the neighboring drone, and the drone can pick up the data from there. Okay, so these are some of the things that you can universities are actually working out. And once this one comes with a low cost, because agriculture essentially is derived with a low cost solution. If you cannot have a high cost solution for the agriculture, then, right? So if this one can become a low cost component, then when you deploy this type of system in the society, or for the larger aspect, right, it can be more productivity, and particularly country like India, where agriculture is the backbone, right? So this is actually is a very a fine area where people don't often look, but it is the place where actually is going to be huge potential, because at the end food makes the difference, at the end of the day, right? So agriculture will become as a key component there. And if your projects is related with that of an agriculture or energy, it has a wider scope. And if yourself is thinking about doing a startup at some point of time, right, then you can think about deploying your knowledge, your skill that is you develop in your university, back into these sectors, and it will be more a blue ocean approach for in the IoT market there. And of course, the second one, which I just mentioned, like I will just mention here, right? So when you talk about the mobile generation, so this is the simple difference for us to understand, like the difference between what is a 3G, 4G, and 5G. So if you want to download, for example, a Guardians of the Galaxy movie, so it will take 26 hours for you to download a single movie using in 3G. But if you do the same thing in 4G, it will take about 6 minutes. Look at the 5G, it's only 3.6 seconds. And as you know that now is most part of the world is trying to move towards 5G. The one I'm talking to you is also through a 5G network there, right? So if this one is going to be a cheaper in the market, right? And you know that data is very cheap nowadays, right? The only thing is like you need to know how to connect these devices using this communication network so that can make your operation to be very feasible and very practical towards the dollars and the cents there. Okay, of course, this is going to be the future when you see that you can a single pole will be a single pole in your traffic light signal might be having a several type of sensing devices embedded within its network, right? And it is a self power, as you can see here. The moment when I say sustainability, it's a self power, so it's powering from the solar panel. In our research lab also we are developing some device which is going to trap the energy both from the water, rainwater, and also for the solar panel. So if this is becoming a low cost, then it can be more sustainable in the long run. And so if you see from here, all this one is nothing but a sensor, right? All this one is sensing, and it need to have some sort of a communication port. That communication port need to have a transmitter receiver channel, and transmitter receiver channel will try to it will make this whole process to be easier in the long run, right? The next one is, as I mentioned, like diagnose is basically like you need to know like what is the problem in the system, because this tag back to the downtime production of of a component or for a particular industrial unit in an industry there, right? So the feature is integrating these type of sensing devices with artificial intelligence, right? Then with some sort of data background, like as Shahrukh just mentioned, big data, for example, right? Based on its previous experience, you come up with some sort of logic and artificial intelligence algorithm, right? That can predict the probable cause, and a probable solution, if it is possible, can be done with an automatic component. So I call this one as a power healing or a self-healing component. And this self-healing will also does the job by itself. Then it will charge through your, for example, in your case, if you have Paytm, for example, it will charge for the service to your PTM, and the PTM, you have to just approve the like the service charges. So typically you will not be seeing any service engineer, but the service has been done already by the system here. So what we call this one as a power healing then. Okay, as we move to the industry 4.0 to 5.0, this is the next big thing that is going to happen in this industry. We call as a digital twin. A digital twin is something like we can control physically, at the same time we can control through an automated system. So like for example, some of the lab experiments when we do here, we might not be having a high-end equipment here, right? But through this network, we can control the equipment from here. For example, if you have a UK, a high-end research lab, research setup is there, right? So we can access those type of research setup from Malaysia, for example, right? Then we pay them for the service we have used, or for the time we have used for the system there. So this is what we call as a digital twins, which is going to be happen, or which is going to be the very common name in at least in when we move to 2024, 2025, when it is become like a practical application. You can see most of them is digital. Just then, as Sharik mentioned, also like a 3D prototype, right? In the conventional system, like when we buy the first 3D printer in 2013, right? We use manual one. That means we draw the picture in SolidWorks or our CAD software, and then we copy that in a disk. Then we put that one in the drive. Then the drive will try to run the system. Then the system engineer or the service engineer, you need to go and look at every stage of development. Like until it comes with a full prototypes there, then we develop this one. Like for example, this is a 3D printed system and fully developed within the 3D system here. But the future is going to, or at least we are moving towards in our Taylor's University. What we do is we make the whole thing to be an automated system, wherein like from the home, right, I can build the CAD file. Then I can send this straight away to the communication through the cloud to the server there. Then it will automatically queue with the number of 3D printing devices available in our lab. And once the 3D printer is free, right, then it will automatically queue back to the system there. Then it will start to print from there. So Once it is done with the printing part there, then there is once again a sensor inbuilt with the 3D printer. Then it will send a message to the service engineer or the through your mobile phone app, right? Then mobile phone will tell like your system is ready or your prototype is ready to be collected from the 3D printing lab. And then we can go manually to collect the printing from here, particularly when situation like this where we work from home. So this is an easy aspect for us to do for a here. So I mean, I just try to correlate this one is because this is going to be the future under here. So integrated smart city, as once again I borrow from what Shahrukh mentioned also, it's going to be an integrated system where your whatever you services use in your home is all going to be interconnected through your common node, through your Wi-Fi there. So you are starting from your energy, starting from your communication you are using, starting from your, for example, the services used in your home, right? Everything is going to be connected through a single network, and through the cloud network it is going to be connected. And as I mentioned, like everything you can visualize everything in your phone, how much power you consume, like how much data you consume, for example, everything you can see through an app that can be developed in your system there. Okay, even government, usually government is very resilient to move towards this type of new initiative. But like most of the governments across the world, including India, is very very uh, like very very shrewd and take up adapt this type of system into their portfolio, and they are trying to integrate all the government services into a single source here. Like in Malaysia, they are trying to come up with all the government sources, government government individual component into a one-stop solution, where you can just put the data and you can see that what is your request and what is the status of your request, and whether it is, has been a process, or what is the stage of the process then, right? So it's what we call as an integrated common platform, where you can connect everything into a common console here. Like it want to know about the city, your temperature, what is the forecast, everything you can see from here. The people, everything you can see from the architecture where they develop here. Like the case of Malaysia, as I mentioned, like this one is a single control console where you can monitor the whole process there. For example, if the waste is higher at a particular part, a particular area, is because of some activities there, then the sensor will initiate a sensing point and tell the waste collecting part to go and do an action there. So there will not be wait until the cyclic process is happening. Like every week they are going to do only for twice. But for because of this type of a system there, integrated system there, it will actually make the city to be more cleaner, or more towards what we call as like a sustainable city, or what we call as a smart city in a whole here. Tailors also, like we do projects which we integrate that one with the industry. When industry comes to us with a problem, then we try to integrate, embed this type of IoT type of devices into the system, that then we want to come up with a system here. The most common, I just tried, because I'm running out of time, I just try to give you a simple application here. Daikin came to us to say that they are not able to motivate uh, the owners to come for service engineering, right? So we don't know what is actually happening inside an aircon, right? We just want to switch on the aircon and we want to feel the coolingness there, right? We don't know like whether it is actually what the air that is coming out of the aircon is good or not, whether it is time for you to service or not, whether your power consumption is like there is a direct relation between your dust that is put inside your aircon to that of your energy consumption. The more dust means the more aircon needs to perform. That means it will consume more energy there. But when you don't educate these type of things to the customers, it's very difficult for them to motivate to go for the service component there. So we come up with an aspect like we put sensors inside the aircon, and we come up with a display where it can show that how much energy is consumed if your aircon is in the normal condition and at this condition there. So when you see the money, automatically you'll get motivated to say, oh, I can save about, for example, like 200 300 rupees from here, right? Then it will motivate for us to look into the solution there. The same thing parallelly also about the health, right? So we don't know like whether the aircon whatever is giving you is good for your health or not, right? So you can also estimate based on the dust content inside, and like it can be connected to your mobile phone to say that okay, you if you don't service this one, this is this amount of carbon monoxide is there, like those type of things actually make the customer also to look into the aircon as a health source, right? Health source to avoid that problem there. Then so that you can become like a more health awareness is one. Statistics show that the 35%, 32% of the health related problem, including your respiratory tracts, comes because of the non-cleanliness of the aircon there, right? So if you have aircon in your home, and then it's time for you to look into the like that those type of aspects there, right? We use a simple system. It's similar to that of next to any other system you see in an IoT type. We put sensor, right, and collect a sensor from here, come up with a program there. We use a model predictive method, right? Collect the data, then it will can push back the data to the cloud. This is our cloud partner. Push to the cloud. That the cloud we write the program. From the program it will go back to the individual customer, like I myself, my mobile phone. At the same time, it will also go to my service engineer mobile phone here, right? In case if I oversee this one, the service engineer will give a call and tell like it is a time for you to service like this. So this project was successful, and we gave this one to Daikin for aspect. This is a unit which they gave to us. Then we build the system and we come up with a simple device. As you can see here, this is a simple device here, and this is a display here. This is of course, from research it go into the commercialization will take longer time for you to adapt this one. Right. So in future, if you're going to see an aircon that is not only showing you the 23 degree or 18 degree centigrade, but it is also going to display you how much is the power consumption, how much is the like a health related like a ratio is going to show in a display part there. The next project also we use a drone, as I mentioned at the start of the seminar also, like we use a drone to be, this drone we develop for an industry in locality, right? They say that they often see that theft is happening around the area here. So we come up with a surveillance drone. But the key aspect of this surveillance drone is like one drone will act as a server, right? In a mobile server. And another drone will go to collect the data from it and come back and transmit through nearest Wi-Fi spot, and this Wi-Fi spot will transmit the data to the ground person there, right? So if you're interested on this one, you can write to me. I can share with you some study material on this one too, on those one. But of course, you need to know that data is going to be the key component in the future. Data is money, as we know that, right? But data will give you an unstructured information because it just gives only the numbers, right? Then we try to extract this number into meaningful data. Like we segregate the data to say that whether it is good, it is useful, it is really critical or not critical like that. Then the next step is like knowledge creation. We based on this data pattern, we come with some sort of analogy to say that okay, this is correct, and I know if the trend goes this way, then probably there is some corrective actions need to be done. Universities mostly stop here. Universities mostly we teach you how to handle the data, how to analyze the data, and how to come up with some sort of a logic there. But a skill-based system, or when you go for the practical application-based system, is what you are trying to come up with an analysis to say that whether what you are thinking or what your programming algorithm will work for the practical solution or not. Okay, so moving forward, I think what universities also is, including myself and also from CUB, also from Canadian University, also we are looking forward to move from the mere knowledge sourcing towards the what we call as like an application based. So that's why we stopped our projects in our universities as zero offer projects from the university, and all our projects are coming from industry. We take the problem from the industry, we solve the problem for the industry straight away there. So I what you guys if you want to ask me as like what is the advice you want me to give, is like you need to move towards the skill based knowledge. At the same time, the skill needs to be applied for a greater cause. As I mentioned, like we need to see that where this is going to help the society in a large. When you say as helping the society, it need to be really low cost. Cost is the biggest factor because nobody wants to buy a high end system for increasing the productivity. Thank you very much for the opportunity for Bala. I hope that this gives some insight into what I intend to say. So I'll be happy to answer a few questions if you have any questions over there. Thank you very much.
Thank you, Arvind. Thanks a lot. I think we have a question from Mr. Faisal. I think probably Arvind, the most probably the question is to you. The question what we have is when we go from 4G to 5G, will there be impact due to radiation since we are going from Mbps to Gbps? Are we going to have health concerns or are we yet to look at it?
Okay, I think it's a good question, and if you ask me, the answer is, of course, there should be some sort of leverage between the health issues and also what we want to do as a comfort level part here. Of course, anything will radiate its electromagnetic around the surface. Even your mobile phone radiate around it. It will create a like a spiral of waves around you, right? Any device, your computer, your mobile phone, your television, even your mechanical car will create a spectrum of wave. We call this one as a vibration. When you start your car, for example, you can see your television is oscillating. It's because it is trying to come and proliferate the another field there. Okay, so there will always be a field mismatch between the particle. And as you move from 4G to 5G, of course, there will be a lot of challenges on in terms of electromagnetic spectrum there. So usually what it does is like the communication ministry will come up with some sort of a standards, right? So you need to go through these standards in order to follow this type of a system. That's why if you see most of the mobile towers is always is an open ended. It will not be a closed ended surface there. So to answer your question, yes, it will cause a lot of harm, but the choice is like whether we want to move towards this IR 5.0, I want to stay back at the level or not. I hope it's try to justify the answer of what we wanted to do.
There is another question which says that will 5G have more impact on older people? Is it going to be a little more health concern for older people? Is another question.
Of course, as I mentioned just then, electromagnetic radiation is radiation. It will harm you, but how much it is going to cause the harm is the biggest issue. If you are very close to tower, of course, it is going to cause you a lot of problems there. Older people or younger people, radiation is a radiation. It depends upon how much it is going to impact you on the larger. Yes, of course, it will affect your health in a larger perspective. Yeah.
Uh, yeah, we take that question, Mr. Prateep Marwa. We understand that the women have been mostly affected. So definitely there will be some kind of a SAR value, a radiation value, which will be a guideline, which will be set by the government. And I'm sure that right now there is a lot of research which is going on, the application of 5G. So I think there are countries which have already started testing it. And the only way by which you can prevent it um, to keep your mobile phone a little bit farther away when you sleep, or to be away from the kids, because it's generally not advisable for the kids to be having access to excessively having an access to mobile and radiation. But today we cannot do with it, because even when the computers came first, there was so much of inhibitions saying that it is going to replace a lot of jobs or it's not good for the health. Obviously, I'm sure that the technology will stabilize because it will take, because 5G is becoming bringing a very radical change. We could do surgeries from thousands of miles away, using synchronization of hand movement. So there's a lot of good things which is happening. At the same time, there are some things which have to be really taken care of. So this is one of the things which needs to be addressed by the regulatory means while going from mega Mbps to Gbps. Well, thank you, Arvind. It was quite useful, and I hope that the questions have been answered, Mr. Faisal. May I call upon Mr. Arvindan, who has been an IoT architect with Caterpillar, to come forward to do his address, please.
Thanks, Bala. Okay, let me just share my screen.
Yeah, you can unmute your video as well.
One moment. I hope people can see the screen.
Yes, we can. Yeah.
Okay. Well, we're going to talk about this very important topic. Especially, you would have heard a lot of talks about IoT everywhere, but people don't really get to know what is in it for you, right? If you want to make a career in IoT, what is it in what does it offer, right? And that's what we're going to look at today. Now, I'm sure a lot of people who have interacted with me since I'm working in this area, a lot of people who have interacted with me have like a set of common questions, which I'm going to discuss today. Okay. So it's mostly like the frequently asked questions. A lot of people come and ask me, mostly software engineers, because they've been working in software and they want to know, do they really need to know hardware to work in IoT, right? Do they need to have electronics knowledge and so on? And similarly, the other way also is true. The electronics engineers come to me and ask me if they need to know how to program, how to code, right? Because they are hardcore electronics engineers, they want to know whether it is absolutely important or not. And most importantly, for any job market, salary is the most important criteria. So what is the salary like? You know, how much am I going to get if I get into IoT kind of jobs? Is it one of the highest paid salaries, or is it an average paying job, right? And obviously, a lot of people assume IoT is kind of very new, which is true to some extent, but they want to know, how is the job market, right? Are they really a lot of jobs out there, or is it like still very a beginning area and it's going to take some time, and so maybe we should not get in right now, kind of a thing, right? And also there's other obvious question, because of just like Bala mentioned, when computers came, people were worried it's going to take away jobs. Now a lot of people are questioning, due to a huge amount of automation that IoT can bring in, will it take away jobs, right? So this is a very, very valid question, and I'm trying to answer most of these questions in this session. Okay, so uh, before I get into some of this, right? Question: should I have hardware knowledge for software people? It's a tricky question. See, if you are working in a startup, right, a small company which is wanting to do IoT products or solutions, typically, if you're a software engineer working in a startup, what do? You kind of do everything, right, end to end. You call yourself as full stack engineer. You do the UI, you do the backend, you do the mobile app development, almost like end-to-end products, right? Similarly, if you're going to work in an IoT company, which is a small company or a startup, you probably would end up doing end-to-end, including the hardware. Obviously, it's not just going to be one single person, but you probably, as a developer, an IoT developer, you will be working very closely with electronics engineers. Or if you're an electronics engineer, you probably will also end up doing some code and app development and things like that. So eventually, it'll become like a full stack. Now, the full stack extends beyond software and includes hardware as well. Similarly, the second question kind of gets answered there, right? So if I'm a hardware engineer, do I need to code? If you are in a smaller company, maybe yes. But large enterprises typically, like we understand, even for software, you have a separate team which is working on the front end. You have a separate team who's working on a back end, and somebody is working on databases. Somebody is managing the DevOps for you. For every activity, there are different departments or different teams who handle that. Similarly, in larger enterprises, you would have a dedicated hardware team. You would only be working on the hardware components. You may not be required to do any software development there, except for embedded development, obviously, right? So there are companies which are just like, even there are large enterprises where there are full stack engineers. You would have certain companies who are working on certain products where you might have to do end to end, but it's all depending on the company and the role that you're playing. Okay, so I think that should answer your first two questions. What is the salary job market? Okay, let me show you a simple example here. A simple job search in Naukri today. Just now, I just did a simple search for IoT. It kind of brings up almost 4,493 active job postings today, right? So you could see there's a lot of jobs available for developers, for lead engineers, for architects, for embedded system engineers, almost in almost all the areas across all the cities in India. Okay, and to answer your question about salary, you could clearly see here what is the kind of salary that is being offered here and what is the amount of jobs available at all categories, right? It could be a fresher, it could be an experienced personnel. There's job for almost everyone here, right? So there's a lot of job openings. The primary reason for this is because most of the companies, if not all, are looking at IoT as a very, very key technology. And if not today, they are looking into venturing into that area. A lot of companies have already invested a lot of millions and billions of dollars in it. So the IoT industry itself is growing, in an exponential way. So obviously that will result into a lot of jobs, right? So to answer your last question, will it take away jobs? Maybe some of the monotonous jobs that a human being, a smart human being should not be doing. Yes, I would want to see those jobs being taken away because I feel human intelligence is much more worthwhile not doing monotonous jobs. You could automate them, but instead their knowledge and their intelligence could be used to probably automate that job, right? So it's definitely going to take away very, very small amount of jobs, but it will going to bring in a huge amount of new opportunities, new jobs available. A new set of businesses are going to open up because of IoT. As we saw, for example, take an example of Uber, right? It's completely internet-based a technology, right? A completely new business domain, right? Completely driven out of internet. And it has introduced a lot of jobs for a lot of people, right? A lot of cab drivers today have found a job because of Uber and Ola. And Uber and Ola, it's completely powered by internet. And to a great extent, it's also a part of IoT, is what I would say, right? It's primarily your mobile device, which is a smart device, and it has GPS sensor. There are people looking for a ride, and that it kind of, the technology connects them all. It is an IoT solution, right? Okay, let me get back to my slide here. Okay, so that kind of should answer your common questions about careers in IoT, right? Uh, well, I'm going to talk about both horizontals and verticals of this IoT industry and where the jobs are available and what kind of jobs are available here, right? Um, so let's start. IoT is kind of spread across all verticals, right? There is no fixed vertical. Just like computers and internet touches almost every aspect of businesses today, IoT kind of touches in the same line, right? And that is why IoT is going to be a huge, huge industry, and there's a lot of opportunities out there, right? It's not constrained to a certain vertical or a certain technology, etc. It's more going to be like a general technology area, and a lot of opportunities going to come up due to IoT. So some of the areas here, the top IoT industries, we could call it as consumer electronics, right? Now you see almost everything is becoming smart. Smartphones, smart homes, smart cities, smart companies, smart buildings, right? All of this is kind of powered by consumer electronic devices. Your Alexa kind of makes your home smart. You have smart light bulbs and so on and so forth, right? So a lot of new consumer electronic devices are going to come up. Now, as a person who's looking for careers, a lot of career opportunities going to come up in those smart home areas, right? For example, just like when mobile phone came, mobile app developer is a new job that came up, right? There's a new opportunity there. Similarly, for smart homes, you will have a lot of opportunities and new jobs that are going to come up. Just to give you an example, Alexa is a smart consumer electronic device, right? Now, today, you could become just like a smart mobile app developer, you could become an Alexa app developer, right? You kind of develop voice-based apps for your smart home, right? So there's a lot of opportunities out there Similarly, we talked about Ola and Uber in terms of transportation, right? So this is again another big area. There's a lot of fleet management, tracking of the transportations, logistics is going to come into picture. So this is going to open up a lot of job opportunities there. Manufacturing is a big area. My friend Arvind talked about industrial IoT, and he explained about the industry 4.0, right? Now, this is a big area. This is where the businesses are making huge investments, right? This is where the money is, right? Now, the industrial automation, industrial automation itself it's a very old area. That way, people still get confused between industrial automation and IoT. It is definitely automation, but it's much more than industrial automation, right? We have robotics here. We have monitoring and control. It's going to give a lot of opportunities for people in the industry to upscale, to connect all those hardwares that are used in industries. A lot of machinery is going to get upgraded in the future where they talk to each other. So there's a lot of work in terms of robotics and mechanical engineers developing new smart devices in the manufacturing segment. I'd like to switch here towards the healthcare, right? Just like computers are playing a very critical role in your healthcare today, IoT is also going to play a very big role there. There are going to be a lot of biomedical devices, implantations, which are going to become smart. You will have smart devices on your body implanted, which is going to give critical your body statistics, right? Whether your sugar levels or your blood pressure levels, whatever it is going to be, right? It's going to be live monitoring and live notification in case something's going to go wrong. So there's obviously a lot of opportunities in terms of new devices that needs to be built. A lot of people in the biomedical area are going to learn about smart devices, how they could implant them, and safety measures, etc., and so on and so forth. Doctors are going to be trained on these devices, how to handle them. So it kind of touches almost everything, right? And talking about agriculture here, that's another very important area for IoT. Okay, so farm production, and it's basically IoT is, if you look at IoT, it's mostly like optimizations, resource utilization, right? Um, and agriculture is one of the most important places where we talk about optimization and resource utilization, right? You want to save water, you want to have the highest yield, you want to monitor the plants and make sure that they are pest free, they are healthy, okay? And you want to know exactly at the right time when to harvest, and so on and so forth. And obviously you want to do smart farming there. Irrigation is a simple example, right? Kind of helped agriculture a lot. But with IoT, it's taking irrigation to 10,000 times the benefit of an irrigation, right? So that's what we're looking at in the agriculture field, and a lot of advanced nations today have adopted IoT for agriculture. It could be farming, could be poultry, could be milk production, and so on and so forth, right? And now this is one area where I think India, being a large agriculture, main agriculture-based country, and a lot of farmers here who have actually moved on from farming, and for financial reasons or whatever, we have moved away from farming and moved into IT sector, right? Now this is an opportunity for all of you guys, right? Learn the IoT, take the technology to back to your farming, right? Try to become entrepreneurs there. Try to make your farm smarter. A lot of people I know, a lot of my friends I know, have a lot of farm still. The parents are taking care of. They're not able to take care of it, but they are working in IT sector here. Big primary reason because of water, because of resources, because of money, right? IoT is going to be a boon for all of you. You would see in large advanced nations, right? If you look at a lot of videos on IoT, you're seeing a lot of advancements in IoT in large nations. You would see large areas of farms. One moment. I'm sorry about it. Okay, so large farms, acres and acres of farm is actually cultivated and controlled by a single farmer, right? Or very, very less human power is required. So that's another very big area where a lot of opportunities available. Okay. Right. These are the verticals we talked about. Now let's talk about some horizontals here, right? So we are talking about IoT is not just about hardware or embedded technology, right? It's going to span across a huge area of job market. Now, it's going to create a lot of direct jobs and a lot of indirect jobs as well. Okay. Now, if you're talking about direct jobs, these are the primary areas that I would say, right? Embedded software development is the heart and soul of IoT. Nothing works without electronics and communication hardware for IoT, right? So due to this, the demand for engineers capable of setting up, working on embedded devices, programming them, setting up networks like Wi-Fi, working on Bluetooth stack, and maybe, who knows, a new set of radio-based or wireless technologies that are upcoming, right? And solving a lot of problems. Like we talked about 4G, we talked about 5G. There could be 6 or 7G or whatever it is going to come in the future, right? So there's a lot of network-related requirements that are coming in on the embedded software development. You would have a lot of opportunities coming up for AutoCAD design, for designing embedded devices, micro electromechanical systems. We call them as MEMS, right? A lot of sensor-based jobs are going to come up. New sensors need to be invented and manufactured. There's going to be a lot of requirement for new wireless devices and so on and so forth, right? So there's a lot of work that is coming in that area. And obviously, for all of these devices to be connected to internet, networking plays a very, very important role, right? Now, networking kind of, the challenge was, we had only millions of devices. Now we were talking about billions and billions of devices. Every single person today probably carries a 2 or 3 mobile phones. On each mobile phone has about 2 or 3 SIM cards, right? Now, all of the SIMs are working on networks, right? Now, take that scale into everything in your house being connected: your chair, your television, your fans, and so on and so forth. Everything is going to be connected, right? And that's going to become that calls for a huge network. And we would have a lot of hardware and software that needs to be designed. New protocols need to be designed to manage them, to control them, and to make it efficient, right? So a lot of work coming into that area. People who are conversant in WPA, Web, 3G, 4G networks. A lot of people working on RFID technology, Bluetooth Low Energy, and other wireless technologies. There's a lot of work and jobs opening up in that area because of IoT. Okay. Now, very important area is the software piece, right? Now, we have hardware, we have networking, and what puts everything together, what actually makes things work is the software, right? That's like the brain of behind IoT, right? And it spans across the entire software stack, right? From the low-level hardware-based, so embedded code till your application, networking, security, cloud computing, mobile app development, analytics, dashboards, kind of covers everything under that umbrella, right? So you would have people, cloud computing is kind of, was a niche area, or kind of a wanted hot technology, right? But now with IoT, it's going to power it even more, because all of these devices are going to send data over internet, and cloud computing is the most ideal platform to control and monitor and access this data from these devices, right? So a lot of technology stack goes into cloud computing. The way you design your applications in cloud is changing drastically, right? It's no longer you develop a program and you deploy it in cloud. That model is changing to developing applications natively on cloud. You have serverless functions, microservices, container-based orchestrations, stream-based processing of data, big data processing. It's IoT again is nothing but big data, right? So big data processing in a streamlined a scalable fashion. Again, because of the huge volumes of devices connected and huge volumes of data that is coming in, you need a computing system that is scalable and can manage those data, right?
Sorry,
That is where, yes,
Arvind, that is a question from one of the participants.
okay.
Dinesh, the question is, as we scale in IoT both on personal and business, cybersecurity threats and vulnerability is a challenge. Can you please share your views on this? Like, how do we handle the data breaches and the cybersecurity threats in IoT?
Yeah. So if you look at, that's my next point in the discussion after cloud. Okay, yeah, I will address that question. Thanks, Bala. Yeah, so just give me a couple of minutes before I move on, right? So that's where the cloud computing is coming into picture, right? The app development in cloud is going to be completely different. Okay, moving on to security is again a very important role when it comes to IoT. Primary reason, what happened in the recent cases of WhatsApp messages being leaked, privacy, etc. Right now, we are talking about almost everything becoming exposed here. We have security cameras in our house. We have smart devices like Alexa listening to us always. You have mobile phones almost everywhere, right? All of these devices are connected to internet and sending constant amount of data. All this data is becoming available to companies, right? Large organizations, which use them in sometimes positive, sometimes in not so positive ways, right? It kind of makes a big question mark on privacy and security. In addition to that, we are also not only talking about data becoming available, it is also control becoming available over the internet. Just imagine your entire house being controlled by some hacker sitting in China or some other country, right? Turning on, turning off lights, or switching on cameras and watching what you're doing. Or it's a big security risk, right? Um, so that's a big area for security engineers to come in and fix those gaps, identify those gaps, work on those areas, and fix them. uh, what is the current state? It is a big question mark. There is a lot of security risk that is there at this point in time. Even advanced computers are not hack proof. We have a lot of issues in managing the security for that. But there's a lot of good part of it is a lot of companies, security companies and organizations are investing huge amount of money in beefing up the security for this. Other primary challenge for security in terms of IoT is because you could have a very secure system if you have a very powerful computer, but look at all those tiny devices, right? Your smartwatches, they can hardly even hold the battery for an entire day, right? It requires huge amount of computation and power. Now, all these security systems, for example, a simple a website on the internet, a banking website, has a lot of security in it, which involves a lot of cryptographic algorithms, which means that it requires a huge amount of computation behind the scenes, right? To make sure that it is basically connecting securely, etc. Now, these tiny devices, it is very difficult to push so much advanced security protocols onto them, right? They are very tiny, they have very limited resources in terms of memory, in terms of power, in terms of computation power, in terms of the electric power as well. And you want to run them forever in a completely remote area, etc. Right? Now, putting advanced security algorithms on it, it's a challenge, right? But things are changing. There are a lot of companies who are coming up with hardware security. There are chips that are coming in which could be programmed with secure encryption algorithms, and thus the devices which are going to be programmed using that devices are much more secure today. We almost every small devices, even the small prototype devices that we use today, like ESP32 or tiny microcontrollers, kind of support a good quality security certificates, right? Equivalent to your banking domain. So it is becoming improved a lot as the day goes by. Okay, but it's definitely just like the hackers, right? You put in a security system which is 1024-bit encrypted algorithm out there, it just hardly takes a matter of time where somebody else breaks it, right? Now, this is always going to be a cat and mouse problem, and thus a lot of opportunity for all of you to enter the security area and be ahead of the mouse, right? So it's an open area. That is why I said it's tricky. Um, you have a lot of security right now, which is improving every day, but it will still be always an open area, right? None of your locks are actually, if you look at our traditional locks that you put to keep your house secured, they are not secured. They're not keeping your house secured. It is only delaying the, the break-in, right? None of the locks are break-proof, right? You take a hammer and break it, it's going to break. But it's just that it's going to awake your neighbors, or it's just going to delay the break-in. Similarly, security is just as that, even in IoT, right? It might be delaying certain things, but it's always an open, risky area, and you have to work on it to actually make it better. I guess that answers the question.
Thank you, Arvind. And I think that gave a good perspective about what is to job seekers, the IoT.
Correct. Correct. Exactly.
Like the overall perspective of this session is just to make the point now, IoT opportunities have accelerated post COVID, and there is a lot more sectors which was not meant to be automated is becoming under automation, right from the transportation segment, including all the automobile majors, including the consumer electronics, and even including those doctors who are not used to online consultations using IoT devices. There are so many devices which are being used. So there is a push and there's a rush to use. And also, there are few things to take care. One is IoT needs investment both in terms of hardware and software. But the beauty is anybody can learn it. There is no restrictions for anybody, and it gives an absolute opportunity of balance of working both with hardwares, softwares, clouds, data analytics, artificial intelligence. We here in Howdy, we excel and pioneer in IoT skilling. But what makes us different from others is we integrate the other technologies. IoT itself may not be that powerful unless you integrate it with a decision making tool using artificial intelligence, or you make something physical reality through robotics, or augmented reality or a virtual reality. It's how effective, it's all about uh, how effective you, yeah, it's all about how effectively you are able to integrate the solutions. So I would like to introduce you to Howdy. Basically, Howdy is one of the brands. It's a skilling and a training brand which focuses on IoT, and it is also a center of excellence in IoT, which is helping students, job seekers, and innovators. So we're going to have a series of webinars. We have several use cases, starting from smart agriculture, smart homes, smart cities, smart healthcare, smart supply chain or transportation, and several others, use cases of IoT. So we're going to discuss week on week about each use case about IoT. And almost all the panelists, including Arvind and Shahrukh, Arvind, everybody spoke about one thing: how do you bring it to reality? How do you commercialize it? You know, so what is more important is not to remain at the prototype level, but how to get to the industry grade level, which is a huge, huge challenge because it has to go through several rigorous safety data protocols, and also reliable hardware and reliable power source is also a huge challenge today. in actual, because I come from an industrial background where we build metro trains, we build several vehicles, futuristic and sustainable vehicles. So it is all the more important with EV. EV is a classic case of IoT. You can see Tesla is an IoT. Almost all the modern cars are IoT based cars. So you cannot separate IoT from your life. But at the same time, it is very much important that we all slowly start skilling ourselves in Internet of Things so that we don't get outdated as the time passes by. So I would like to tell you that you could get more information about us in howdyworld.com. You can connect to us, you can write to us, and you can be also part of Center of Excellence. We are building a Center of Excellence down here in Chennai, which will be expanding it on a pan-India basis, where we would like to get all the great minds here who could contribute, who could discuss, could bring in new products. At the end of the day, we would like to see a lot of products getting developed and then serving the humanity. Even a common man should be able to afford, like what is the use case of smartphone? Smartphone, even a common man is able to afford it. So that's the level at which the IoT devices are going to become. I would take in any questions and answer, and I would. Is there anyone having any questions? Please raise hands, and we'll be happy to answer your questions because almost all the panelists are here. Do anybody have any questions specifically? Dinesh, to answer your question, yes, there is a security data uh, uh, breaches which is happening. There are ways and means in cybersecurity protocols to be done both at the cloud level, and there is something called as an edge computing. That means you finish all the computing at the device itself. That means at the peripheral devices, the sensors, and you encrypt the data and then you send the data. So this saves a lot of power, this saves a lot of security threat, but then still between the nodes of the gateway, the sensors, the cloud, there are several interfaces where today still there is a lot of concern with respect to data security breaches, which the experts are trying to bridge and reduce this. It's like any other software. You have hackers on everything in internet. So IoT is not just something which is away apart from this, but it's one of the fast evolving and developing areas which is more lucrative. And another to say that IoT is very lucrative if you are able to have an end-to-end knowledge on a full stack, including the embedded microsystems and microcontrollers and processors. Is the most sought after by almost all industry players. And more than that, you could also become an entrepreneur of your own, producing devices, producing projects, producing solutions. So here in Howdy, we could help you to become a studentpreneur, to excel in IoT. And we welcome you all to come and have a look at the website, and then we will be happy to help you without any constraints. Because we are having a panel of advisors, both in artificial intelligence, AR, VR, robotics, who are who are developing products in IoT. Thank you, and I thank all the panelists, Arvind, Shahrukh, Arvindan, and my whole team who have been instrumental, have been working tirelessly in making this webinar to happen. So you will see a lot of action in the days to come. Thanks to all the registrants, we have a huge turnouts, and then thanks to all of you who have been supporting us. And we'll come back to you with the next edition of more interesting application of IoT. Thank you. Thank you, Arvind.
Thank you. Thank you all.
Thank you, Shahrukh, and thank you, Arvind. We close the call. Yeah. Thank you, gentlemen. Thank you, Sukanya.